Okay, so today is 3-2. We're going to continue. You're almost doing exactly the same work again, the same things. You're finding the derivative, you're setting your derivative equal to 0, but it's going to tell us even more about the functions. Okay, so we got Rolle's theorem and the mean value theorem. So what we're going to be working with. So Rolle's theorem says, let f be a continuous function. I love it. Okay, let it be a continuous function. If it is a continuous function on the interval a, b included and it's closed, and differentiable on the open ab, so it can't have holes in it and things like that. If f of a equals f of b, what's f of a mean I'm doing? Plugging in what?
Numbers.
Plugging in the a, correct? Plugging in the a to the function, so f of a equals f of b. If these two things happen to be equal, then there is at least one c in the interval, and you notice these are parentheses, correct? So is that included? Or parentheses included a and b?
What?
Okay, right here, are a and b included? There's square brackets. Are a and b included? That would be a yes. Parentheses, are a and b included? No. So there at least exists one number between a and b, not inclusive, where f prime of c equals 0. What does it mean f prime of c equals 0? It means the slope is what? The slope is what? 0, meaning it is a maximum or a minimum. Okay? We're using what we did yesterday in today. That's why it's so important to keep on every single day. So I have two pictures here. I have one that looks like, this portion of it looks like a parabola, yes. And you see that A and B both lie on line D, yes. So that means both f of A and f of B would be the same. So there is some point C where the slope is 0 of the tangent line, meaning it is a maximum or a minimum. Both of these show maximums. They do not have to be just maximums, okay? So the next one, is the same thing happening?
Yes.
Yes.
But would it be not continuous because it has a sharp point?
That's my problem. Is it continuous?
No.
No, it is not continuous. So these things happened, yes?
Yeah.
But it says, let f be continuous on the closed interval. Is this a continuous function? No. But can it still have a max or a min? Yes. But guess what you cannot use? The Rolle's theorem. If it is not continuous, you have to do this by other means. Okay? We haven't done anything.
I know, but I'm just confused.
Just stop. Just
Because
quit.
yesterday-
Okay, please listen to me. Quit telling yourself you're confused because you haven't even used it. We have not even done it yet.
No, I'm not saying about the Rolle's theorem. I'm just saying like about yesterday, you know? Because you said all sharp points are not continuous.
Right. I just said I agreed with you. This is not continuous. So Rolle's theorem doesn't work. We have to use other methods that we will discuss later on.
So that one is D and E. It does not exist.
Well, no. Rolle's theorem tells I can't use Rolle's theorem to find the max or min. I will have to use something else. Okay? So I can't use Rolle's theorem, but there will be something else that I can use later on. Okay, it says find the two x-intercepts of x squared minus 3x plus 2 and show that f prime of x equals 0 at some point between the two. So how do I find the zeros?
You equal it to 0.
I equal it to 0. So it jumped. So x squared minus 3x plus 2 equals 0, then what?
0. Find the derivative. No, you have to.
I just want the zeros. I want the x-intercepts, guys.
I know. You have to. I don't know. Factor or something like that.
Yeah.
Yeah.
So factors of 2 that add to 3.
2 and 1.
So -2 and -1.
Yup.
And so x equals what and what?
X equals 2 and 1.
Okay. We're always going to put smallest to biggest. So x equals 1 and 2. And then it says, then show that f prime of x equals 0 somewhere between those 2 points. So now I need to find the what?
The derivative.
The derivative. So what is the derivative?
2x minus 3.
And then I have to set that equal to what?
0.
0, because it tells me to, right?
Yes.
So x equals what? Add 3, divide by 2? Is 3 halves between 1 and 2?
Yeah. Wait. I don't know.
Is 3 halves between 1 and 2?
Yeah.
Okay.
I was just
Did
confused.
Rolle's theorem work? Yes.
That's Rolle's theorem?
One way to look at it, yes.
So explain the third step,
Which third step?
the one under the factoring junk.
Well, it says, in the directions, it says, and show that f prime of x equals 0. So we had to find f prime of x, and we had to set it equal to what? 0. At some point between the two x-intercepts. Well, here's my x-intercepts. Is 3 halves between 1 and 2.
Yeah, but how did you?
I added 3 divided by 2.
So if you were to get something that wasn't in between 1 and 2,
Well, it wouldn't be. If, like this, looked at it from this direction of just factor and find the 2, I'm going to give you 2. And we're going to have to see if we can use Rolle's theorem. This way, there's no way Rolle's theorem couldn't work. This kind of proves it. Just like I say, your assignment, you have like 1 to do like this, and the rest is, can Rolle's theorem work? If it can't, tell me why. Okay. Are we ready? Okay, so the next one says, this is the exact instructions from the book. I love that it's a paragraph, but I wanted to show it to you. It says in exercises 11 through 24, do not write this all down, it's in the book. Determine whether Rolle's theorem can be applied. Well, Rolle's theorem says f of A has to equal what? F of B. So the first thing I need to check is what?
If it equals.
Is it equals to each other. If it doesn't equal to each other, can I use it?
No.
No. Okay, so the first thing I'm going to do is check that. If that works, then I'm going to do this. Yes?
Boom. Yes.
Okay. Actually, it's going to equal something. Just a second. Okay, so all that says, it says, if it can be, use it. If it can't be, say why. Well, it's pretty going to be easy. It's going to be either discontinuous, yes,
Yep.
or it's not going to equal.
Okay.
So, first thing I have to do is f of 1. Oops. So, f of 1,
Why do you have to do f of 1?
because that's A, and that's B.
Oh.
Yes? So, f of 1 would be 1 minus 5 plus 4, which is what?
0.
0?
Yep.
Okay. And f of 4 would be what?
0.
Well, 16 minus 20 plus 4,
Yep.
which would be 0.
Yep.
Okay, so then you write f of 1 equals f of 4 equals 0. Okay? So then I have to, so that worked. So now I need to go find it. How did I find it? What's my next step?
Derivative.
Derivative. So what's my derivative?
2x minus 5 minus.
2x minus 5. And that derivative should come that quick, right? Okay, so now I have to set that equal to what?
0.
0.
Oh.
X equals what? Other way around.
5 over 2.
5 over 2.
I knew that.
Okay, is 5 over 2 in between 1 and 4?
Yup.
So it is a critical number.
Number. Whoa.
And that means if I plugged in 5 halves and I got my y, I would either have a max or a min, right? And since this opens up, it would be a minimum, wouldn't it?
Yeah.
So 5 over 2 is my minimum.
Oh.
And we're just using stuff we already got back there.
Wait, how do you know if it opens up?
Well, because the A is positive.
How did you know that was a minimum?
Because A is positive,
It opens up, Sadie.
it opens up.
Okay.
So, same directions.
Yeah, same.
Okay. What's the first thing I got to do? F of x equals x minus 3 times
Yes.
x plus 1 squared.
You have to plug in -1 and plug in 3 and then see if they equal each other.
Yep. So do it. It will be much quicker to do it on your own, right? And don't multiply it out. Just plug them in as they are.
Oh, I wasn't planning on it. Don't worry.
Did you get them to equal?
Yeah.
Okay, so f of -1 equals f of 3 equals 0. So Rolle's theorem works, so I keep going. So what's my next step? Derivative. Now, this derivative is going to be a product chain, correct?
Yeah.
Now, your other choice is to multiply it all out, which we're going to have to do some multiplication anyway, but I don't think I want to start. Okay, so product chain says derivative of the first, which would be just 1, wouldn't it?
Yeah.
Times the second, plus the derivative of the second. So here's where my chain comes in. I think my pen died again. How nice of it.
So it's 2.
So it's 2
X plus 1.
x plus 1 times x minus 3.
Oh. I thought we were doing chain rule.
Well, times 1. Okay, yes, you can put times 1 there if you'd like. Sorry. I was skipping the times 1.
Times 1.
Because the inside, the derivative of x plus 1 would be 1.
So 1.
Okay, so now I'm going to have to set this equal to 0, but before I set it equal to 0, do I have to multiply all this out and combine like terms?
Yes.
Yes. So this x plus 1 is x plus 1 times x plus 1. So that would be x squared plus 2x plus 1.
Yeah.
And then I'm going to make this 2x plus 1 so I don't have to distribute a 2 when I'm done. So then I get what? Plus 2x squared minus 6x
Whoa.
plus x minus 3.
I guess so.
I'm just foiling this. And then I got to do what? Combine like terms.
So there's no x squared, x cubed.
So we got 3x squared. Yeah? Minus 4x.
Plus
I got
that.
minus 2x. What did I do wrong?
Oh.
I got plus 2x. Wait, what are we working on right now?
Combining like terms.
Oh, never mind. I got it.
Oh, we got another x.
Where? Oh, yeah.
Yeah, we do.
Oh, I see.
Should be plus 3x. Or minus 3x.
I actually added the plus x and didn't combine them. I had like minus 4x plus x.
But I still get negative 4x.
2x minus 6x.
Oh, guys, 2x times x plus 1 is 2x plus 2.
I was so confused on why you did that. I was like, where did that one come from?
So that makes this a 2 here, doesn't it?
It's what a 2?
Right there.
Okay, then why not change our...
So then that's going to be negative 2x.
No, it'd be but our 3 on them would be negative 6.
No, it wouldn't.
Yeah, huh?
What 3?
Negative 6x.
Oh,
plus
down
x.
here. But this there you go. Negative 6. That negatives. And that's horrible writing. I wish my pen would not die on me.
Yeah, I got negative 2x.
Yes, that's what we should have had. That's what I got earlier this morning. And then I got 1 minus 6 is negative 5. Okay, so now I got to factor because I got to set it equal to 0. So 3 times 5 is what?
15.
15. So however you factor, the factors of 15 that have a difference of 2 are negative 5 and 3, yes?
I guess.
Well, don't negative 5 and 3 have a difference of 2?
No.
What's negative 5 plus 3?
8.
Negative 5 plus 3.
Negative 2.
And that's what we needed.
Whenever you say difference of 2, I think that they can be divided by 2.
No, difference means subtraction.
Well, I swear, there was one time where you're like, what's the difference, like, in the difference of 2 being 4? And you said, yes. And then you showed me how, and you divided it.
Okay. So however you factor, it factors to 3x minus 5 and x plus 1. So remember, I don't care how you factor, you just have to be it. Right? Okay, so now I set both of those equal to 0, and I get x equals negative 1 and
3/5.
how about 5/3?
Yeah.
Add 5 divided by 3. You did what Sadie tried to do a little bit ago. Okay, are both of those between, now between
No.
negative 1 and 3?
No.
No.
Negative 1 is negative.
Negative 1 is negative 1, right? So it can't be negative 1, it has to be what?
5/3.
So the critical number,
It's 5/3.
it's 5/3.
This is too confusing. I'm still working on the first assignment. And I'm already stuck on number 25.
Can you stop, please? Okay, what time is it?
21.
Okay, we're good. We will do the mean value theorem tomorrow. I am going to put it up there in the video, so if you guys would like to go copy it down tonight, that would be appreciated. Okay, and then we can talk about what it actually is. You might want to sketch the picture because I'm going to label some parts, okay?